At time t equals 0 seconds, the position vectors r meters and velocity vectors v meters per second of two particles A and B are as follows. Ra is negative 4i minus 23j, Va is 4i plus 3j, Rb is 45i minus 15j, Vb is negative 5i plus 2j. Determine whether, in subsequent motion, the paths of the particles cross or meet. If they do, determine the position vector of this point and determine if a collision between the particles is involved. So consider the situation. This is one path, this is another path. We're interested in whether the paths cross. For the particles to actually collide, they would need to be at this point at the same time. So what I'm going to do, if we look at A, we're going to say that's negative 4, negative 23, plus lambda 4, 3. And then RB is going to be 45, negative 15, plus mu, negative 5, 2. I'm using lambda and mu rather than t because we're interested in where these cross. So, if I look at the I component, we have negative 4 plus 4 lambda, and that's going to be equal to 45 take away 5 mu. If we look at the j components, we've got negative 23 plus 3 lambda, and that's going to be equal to negative 15 plus 2 mu. And I've just noticed a mistake in that the I component, this one is actually 45, not 15. So we want to eliminate lambda or mu. So if I do equation 1 times 2, that gives me negative 8 plus 8 lambda is equal to 90 minus 10 mu. And equation 2 times 5 would give me negative 115 plus 15 lambda is equal to negative 75 plus 10 mu. Now if we add those, we get negative 123 plus 23 lambda is equal to 15, and the mu's cancel out. So 23 lambda is going to be equal to 138. And that gives me that lambda is equal to 6. Substituting back into equation 1 gives me negative 4 plus 24, 4 times 6, is equal to 45 take away 5 mu. That gives me 5 mu is equal to 45 take away 21, which is 24. So that gives me that mu is equal to 24 over 5. So the paths cross, and we knew that that was going to happen because they're not parallel. The only way that they might not cross is if we actually found that lambda or mu was negative, and that means that the paths actually cross, but it's before one of the particles actually starts. So that can actually happen. Remember, we've got particles that start somewhere and they're moving. like this. So they might actually be moving apart like so, and then if you trace the paths back, they cross sometime in the past. But they do cross because lambda and mu are both positive numbers, but the particles don't collide. And that's because t is 6 when one of the particles is there, the first one, A, and t is 24/5 when the second particle is there. So they're there at the point at different times.